This is section 2.5 in your textbook. I'm taking a look at page right now 271, and make sure that you can graph those common graphs very easily over here. And we're going to now take a look on transformation of functions, which is basically taking one of those main functions and moving it either up, down, right, left, maybe sometimes just flipping it over the x-axis or the y-axis. Those type of transformations, also stretching the graph or shrinking it, either vertically, which we will concentrate on more than anything, or also horizontally. So now if you take a look at the first transformation that we are going to take a look at, it's called vertical shifts at the bottom of page 271. And they're telling us over here that we're going to look at three graphs whose shapes are the same, and they are looking at the function f of x is x squared, g of x is x squared plus 2, and then they're looking also at one more function on the next page over here, which is h of x. So let's concentrate on that page right here, and let's see how they're writing those graphs in the first place, and also let's take a look at how we can go from the basic graph of f of x is x squared to those two other graphs for g and h. So if we were to write over here that, let's see, just one second. So if we were to go ahead and write what they told us, that f of x so let's say we had over here that f of x is equal to over here x squared. So if we wrote the function, we could write f of x is y, and that's x squared. So remember that this is a parabola passing through the origin, which is a black graph that they are giving us. Now if you wanted to graph the graph of g of x, which is x squared plus 2, another way to write g of x would be that it's g of x is equal to, remember x squared is what we agreed to call what? F of x. So instead of x squared, put f of x. And then you're still adding 2 to that f of x to get g of x. So whether you write, your new equation as y is equal to x squared plus 2, remember y is always any function you're talking about of x, so y in this case stands for g of x. You could say either y is x squared plus 2 or g of x is f of x plus 2. Whenever you say something like that, you need to realize that your main function which you had before is going to be used as a template, and then because of the plus 2 right here, the plus 2 right there, then you're going to have a vertical shift of the graph of f and that's going to be 2 units up because it says plus 2. Okay, so now notice that the vertex was right here at 0, 0 for the function f, but now for the function g, the vertex moved up to the location 0, 2, and the same thing for each point that you have, on the graph of g is obtained by taking each point of f and shifting it 2 units up, and so on. So let's remember that if you have, let's say over here, if c is a positive real number and you have y is f of x is your main graph. Now if you want to consider y is equal to f of x over here plus c, okay, c being positive, so it's like we just had y is equal to f of x plus 2 because c is 2 in this condition here, then this is going to be what? A vertical shift, okay, it was 2 units up when we were talking about the specific case, but in general it will be C units up. Okay. So now let's take a look at the other function they are graphing, which is the function h of x. Okay, so let's check that out. So now if we're taking a look at what we have for h of x, remember that your main function is f of x is equal to x squared. Again, y is x squared. Now if you're talking about h of x, let's see how they define h of x. They said that h of x is equal to x squared, in this case minus 3. So let's see how we can think about it. We can write it as h of x is equal to, don't forget x squared stands for what? Stands for f of x. So you can write h of x is, now I'm saying x squared, so call it what it is. It's f of x. Take away 3 now. Okay, so whenever you write something like this, whether you write it as h of x is f of x minus 3, or whether, remember again, anytime you say a function of x, you can call that plain y. If you say y is x squared minus 3, and let's say your main function was f of x is x squared, then how do you go from your main function to either this equation or this written that way with functional notation? Notice you have a function here, so that's called functional notation. So whichever one you have, then you need to realize that when you have y is equal to x squared minus 3, or you can say h of x, or, is f of x minus 3, whenever that happens, that because you have, in this case, a negative number following your main function, x squared or f of x, then this is going to be a vertical shift. But it's not going to be, up anymore, because it's not a plus like we had here. It's a minus this time. So because it's a minus sign, then it's going to be a vertical shift over here of the graph of f, and it's going to be 3 units down. Okay, so that's what we have. So notice the vertex, which was 0, 0, is now at the point 0, negative 3. So this vertex fell down by 3 units, and so did all those points right here.